is positive when in first quadrant and third quadrant. So your angle is, you got your first angle which is in first quadrant. So to be in the third quadrant, what will be your choice? You can write x equals to pi plus pi by 4. That's how you will get into the third quadrant, right? And this is going to be 5 pi by 4. And these are the exact two angles you, so you have, how many answers you have? How many angles you got? You have 4 answers here, right? These are the two answers, 0 and pi, third answer, fourth answer. As you know from the beginning that since we are solving the trigonometric functions, even if we don't have quadratic equations, even if you don't have any equations of high order, you will have something like this where you will have more than one answer. So for this equation, we tried to solve it using the trigonometric. We tried to solve it using the factoring, and we had we tried it using econometric. So we got like sin x times tangent x minus 1 equals to 0. From there we concluded sin x equals to 0 or tangent x minus 1 equals to 0, and then sin x equals to 0. So x will be either 0 or pi. Tangent x equals to 1. From there we know that x is either 45, or since it may be in third quadrant as well, because the S is restricted by 360. So still we can take third quadrant, which will be pi plus 4 by pi, that means 5 pi by 4. So we have all possible 4 answers. X will be 0, x will be pi, x will be 4 pi by 4, x will be 5 pi by 4. Remember, you probably remember that yesterday we tried to solve the same equation, and then we did some kind of factoring, right? No, not the factoring. We cancel out the sin x. Okay. But the factoring is a good choice here, because sometimes we don't want to divide by trigonometric functions, because dividing may put you a little bit in a problem, because we don't want to divide something by 0. So we always want to avoid those kind of divisions, because if you are trying to divide some trigonometric functions by another trigonometric functions, which can be 0 in sometimes. For an example, let's say if you are trying to divide an equation by sin x, the risk is sin x can be 0 at 0, right? And there, at those points, your functions are getting undefined, and you probably don't want to do that. So when you are solving an equation, your best bet will be don't divide by, because we are at the beginning phase, and I just did not want to mention that at the beginning. I don't want to confuse you, but don't try to divide by the trigonometric functions, because within that range, most of the cases, you will find something. For an example, let's say if you divide the earlier equation, let's see, if you divide this by sin x both sides, you can still solve the problem, and you will not have all these values because you are missing something. What you are doing is you are dividing both sides by sin x, where the x can be 0 to 360. Now within this range, there are 2 points of x which are 0 and pi. At these 2 points, sin x is 0. So basically you are dividing the equation by sin x, which makes your whole thing undefined at these 2 points, because at those 2 points you cannot make that division. Do you see what I'm saying? Because if you are considering the division, make sure that within that range, the trigonometric functions you are using for division is not 0. If it is 0, you probably will not be able to do that. You should not do that, because this function will be undefined. Okay. So the better choice in those cases is the factoring, because in case of factoring, you are basically avoiding that route. You are not doing that at all. Now let's try this again by factoring. So what will be the first step? Remember, the right side is going to be 0 in case of factoring. So first step is make the right side 0, and then see what will be the largest possible factor you will have, and then take that item as a common factor, largest factor, and then just you probably will have something like this one, that sometime, so there will be a product of two factor. All right, so here to make the right side 0, you can subtract 6 sec theta from both sides. Then in the left side you will have 5 sec square theta minus 6 sec theta, and the right side you have 0, so it's equal to 0. Now you are ready to do some factoring. What you can do as largest common factor is you can take sec theta here as common factor, and then you will be left with 5 sec theta minus 6. So your factors are sec theta and 5 sec theta minus 6. So from here we can conclude that either sec theta equals to 0. If the sec theta equals to 0, your restriction is 0 to 360. So where the sec theta is 0. Remember the relation between sec and cosine. Sec and cosine are inversely related, so they are reciprocal to each other. So any clue? You can also do it here. For example, you can try the inverse function. Oops. Inverse of 0. Oh, that's the sign, but let's see. Is there any value of sec which is 0? Because whenever the cosine is 1, the sec is also 1. But whenever the cosine is 0, the sec become undefined. So when is the tangent is 0? 0. Do you remember those charts that we had for all the trigonometric functions? For an example, the other side is a little bit easier, because what you can do is you can write 5 sec theta equals to 6, and then you can write, okay, so sec theta equals to 6/5, and then you can convert it back to cos theta and do the reciprocal to the other side, so it becomes 5/6, and you can find the cos inverse for this one and get the angle from there. What is theta for this one? Because I don't think there is any value of sec which is 0. Because the sec theta, sec 0 starts from 1, and in sec 90 it goes all the way to undefined. So basically it starts from 1 and it keeps increasing all the way to 90, and then from 90 to 180, again from undefined it gets all the way to -1. So because all the values are negative there, but none of the values are 0. So technically you will not have anything from this side. That you are getting from the from the factoring, but theoretically there is no value of sec for which it becomes 0. But here you can get some. So if you do the cos inverse of 5/6, what do you get? Cos inverse of 5/6? 34 in degree. Okay. So let's write it in the degree, since this is 34. Now what else? First of all, the value of the cosine is positive here. So what are the other angles where the value of the cosine is positive? Quadrant 1 and quadrant 4. So you already have something for quadrant 1. Since we are talking about the quadrant 4, what do you want to do? Subtract 34 from 360. You will have another angle which will be also the right angle, which will be also another answer, which will be 326. So these are the possible two angles. But remember, this is an example of in some situations you will end up with something like this. You probably will have something from the factoring, but because of the trigonometric function, you will not have any answer for that part. It's also possible. Any question here? Because every trigonometric functions has a range that it varies from here to here. Okay, so sec do not have anything in 0. All right. Basically, so let's look at something here. If you look at these equations, first of all, look at the angle here. Left side, the angle is 2x, and the right side, the angle is x. So the typical option is you want to go by the trigonometric identities. So remember the formulas we learned in the last 2 sections. The formulas we had for the double angles, half angles. Let me give you a clue. Do you see any double angle formula that makes the angle half at the right side? All the double angle formulas are listed in the last page of the formula pages under the double angle formula section. do you see any double angle formula for cosine theta which can be applied here? Because now we are talking about trigonometric functions and trigonometric identities which can be, trigonometric equations where we can apply the trigonometric identities to solve the equations. Because the angles are not matching, so which one you can apply? Cosine 2x equals to cosine x. In the left side, for cosine 2x, you can apply the trigonometric identity, which is, you have three options for cosine 2x, right? One is just cos square minus sine square, another one is 2 cos square minus 1, another one is 1 minus 2 sine square. Now the best one I think would be this, 2 cos square minus 1, because you want to make it you can make it just like quadratic function by making this. And then if you bring everything in the left side, or if you just subtract cos x from both sides, then your equation will look like 2 cos square x minus cos x minus 1 equals to 0. And at this point, you have multiple options. One is either you can go by the basic, just applying that formula, x equals to minus b. So here the cos x will be what? Minus b plus minus b square minus 4ac divided by 2a. That's one option. Another one is going by the factoring, middle term factoring. So let me give you a couple of minutes so that you can get your cosine x, and then we'll talk about the angle. So what is our answer here? So cosine x equals to minus b plus minus b square minus 4 ac. Oh, it's not b. It's minus b, so this is plus 1. So it's a. So now you have 1 plus minus 1 plus 8 divided by 4. So it's 1 plus minus 3 by 4. So the answer is going to be 1 and negative half, right? So you have two possible choice or answer, 1 and negative half. So if the cosine x equals to 1, what are the angles? Zero. Okay. And what else? Anything else? Cosine x equals to 1. So one option is 0 degree because cosine is 1 at 0. Any other option? Any other choice? Nothing else within 360 because it will be 0 again. It will be 1 again at 360 because it's 1 at 0, it's 0 at 90, negative 1 at 180. 0 again at 270, and then so because you cannot take 2 pi because 2 pi is excluded. So there's only one option which is 0. Let's write it in the radian. What is the other option for, okay, what is the option for cosine x equals to negative half? Now first of all, half gives you a lot of information. So it will be something like 60, right? But at the same time, value is negative, so it's not in the first quadrant, it's not in the third quadrant, I'm sorry, the fourth quadrant. So it will be either in the second or it's either in second or third quadrant. So how do you know? What do you do? X equals to pi plus 60, x equals to pi minus 60. Because if you do the plus 60, you are falling into third quadrant. If you are doing minus 60, you are falling into second quadrant. Since the value is negative, so you know that that must be in first or third quadrant, second or third quadrant, because it cannot be in the first quadrant because everything is positive. It cannot be in the fourth quadrant because cosine is positive there as well. So for the first one here, the value will be 4 pi by 3, and here is 2 pi by 3. So now you have three answers: 0, 2 pi by 3, 4 pi by 3. Remember again, probably like yesterday we were discussing about this point. For sine and cosine, you will always have 2 points within 360 where the same point is repeated because of this. Because if you try to draw the curve of sine and cosine, this is the sine, but you know, cosine is for same. If just the only difference is cosine is like this. But if you look at this one, let's say negative half, let's say this is 1, okay? So the negative half is this. If you look at this, you will always find two different points where it is intersecting. So that's why you will always have two answers. But for this one, we do not have two answers because we excluded 360. You are not taking 360 because 2 pi is not included. Otherwise, you will take 2 pi. So in case of sine and cosine, that's not true for tangent though. For tangent, you will always have one value because remember the curve for the tangent, that looks something like this. So within the period. So it doesn't matter how you draw the curve. It's not like that. It's like this. So it doesn't matter how you draw it. You'll never have two intersections. Okay. So within the period, tangent will always have one point. But remember, the question sometimes doesn't include the period. The question is, let's say your equation is for tangent, but the restriction is given up to 0 to 2 pi. Now whenever it is 0 to 2 pi, we are talking about two period for tangent. Because within 2 pi, you will see two period. So again, that might be true that within 2 pi, what happens? Within 2 pi, for tangent, you will have something like this. This is the first period. Let's say this is the second period. Draw a horizontal line, 2 points. So be careful about those, because you know all the knowledge that we have so far, use it, because those are also important here to visualize that what you are doing probably will have some meaning here. That makes some sense. If it is in two period, so it must have 2 points there. You will not have 2 points in, but if it is 2 period of cosine or sine, you will have 4 points there. But in general, most of the questions will be considering 0 to 2 pi. Most of the cases we have so far, what are you saying? But it may be different though. Let's try another one. But here again, we'll be applying the trigonometric identities. You know, we are just book tried to divide all those problems into different categories because they wanted to show you that you can solve the equation using all different methods we have. So here, in the left side, you should see whether you can apply any trigonometric identity that you have seen in last couple of sections. Look at the last page of your formula and see whether you can apply something in the left side. All right, so did you find anything? No? Are you sure you don't see anything? I can see something. But let's see. All right, so you have 4 sine x times cos x equals to. Okay, now here we can write 2 sine x cos x equals to 2 times 2 sine x cos x equals to square root 3. Any clue now? No? Are you sure? For this one, is there anything there in the last page? So for 2 sine x cos x, we can write sine 2x. There is a formula in the double angle formulas. So here now we can divide both sides by 2. Sine 2x equals to square root by 3 by 2. Now what? Root 3 by 2 equals to sine 60, right? That's sine 60. So what are the possible options you have? You will have 2x equals to, because it's 2x, which equals to pi by 3 sine 60. To make it generic, because we know that there are 2x, because remember I said that if this is not x, something else, we always make it generic. And then later on we'll apply the values of n and see whether we'll take everything as long as we are not exceeding 2 pi. So remember the range of, to make it generic, will be adding 2 and pi because it's sine. So the period of sine is 2 pi, and we will multiply the period by n times. And then we also can take this. One is pi by 3, right? One was pi by 3. That's why we took this. Look at the sign carefully. There are several other options, right? Because the sign, the value is positive. So you probably will have 2 values. This is one, and we got one from here. You have this second quadrant as well, right? Because the second quadrant sign is positive. You might have something there, right? What is that? Pi minus pi by 3, right? And again, to make it generic, 2 and pi. If we write it fully, after doing the math, it will be 2 pi by 3 plus 2n pi. We are not done yet. So what will be the x? Because in the left side we have 2x. So we have 2x equals to pi by 3 plus 2n pi. So to get the x from here, we divide both sides by 2. So we have pi by 6 plus n pi. Now here, for n equals to 0, oh, I wrote this one. We had 2. Okay. We have 2 separate options, so we'll go by both. So the n equals to 0. This is x equals to pi by 6. For n equals to 1, so you will take all the values as long as it's not, the x doesn't exceed 2 pi. Let's check whether when n equals to 1, you will have x equals to 7 pi by, let's add it, pi by 6 plus pi, which is 7 pi by 6, right? Still that is less than 2 pi. for n equals to 2, x equals to pi by 6 plus 2 pi. We cannot take this because it will be more than 2 pi. So let's stop here. So these are the two values we have from the first equation. We have one more equation, which is 2x equals to 2 pi by 3 plus 2n pi, and from here x equals to, we divide both sides by 2 pi by 6 plus n pi. Now again we'll do the same thing. N equals to 0, x equals to 2 pi by 6, n equals to 1, x equals to 8 pi by, okay, let's make it a little bit simplified, because 2 pi by 6 can be written as pi by 3, which makes it a little bit simple here. Pi by 3. So now, if n equals to 1, this becomes 4 pi by 3, so still we are fine. We cannot take n equals to 2 because it will exceed 2 pi. So now you have 4 answers. What are the answer? X equals to pi by 6, 7 pi by 6, pi by 3, 4 pi by 3. These are all the 4 answers we have. Any question here? You have question? But think about this. We have 2 different parts, so that's why we went there and we worked with both parts separately. And this time we made it generic because this was not x, it's something else. If it is not x, 2x something, then we always add the generic part and then we apply the n equals to 0 and all integer, positive integer, and see what are the possible values of x. Now the next section of the book, this part we want to use the calculator to solve the trigonometric equations, but interesting is what the book did was they applied the same formula we tried before, which was ax squared plus bx plus c. So if you have any quadratic equation like that, you will know the ABC, and then you can do the math in the calculator, just like that. You see what I'm saying? So we already know how to do that. So what we'll do is we'll just, once we have the quadratic equation, write the equation in generic form and then find the ABC, and from there you can always apply the ABC into the formula. We did a lot of examples. So, and then you can get your x's. So we will stop here for this section, which is the last section of the chapter 5. Let's look at a couple of, see, all these are like, if you know the ABC here, for an example here, your A is 1 here, B is 5, and C is negative 8. So once you know that, you can apply it to your equation and then solve the equation using the calculator, just directly using the calculator. But there is another way of solving, but it's up to you. I probably will post some video. I just also had a video here. And these are some examples from the book, but let me see whether I got something here, probably just to make sure. I probably will I'll probably add this in pause, because this is a video of how you can graph those and how you can solve the equation. So all right, so let's stop our